Hello everybody, welcome to Mr. Herder's Physical Science class. Today we're going to be talking about the behavior of gases. One of the main things that we need to know about the behavior of gases is that gases respond to changes in pressure, temperature, and volume in predictable ways. This is kind of the main idea. It's kind of interesting because gases comes from the Latin word of chaos because the molecules inside the gas are constantly moving around and changing direction, location. And so even though that is kind of chaotic, we still know that a gas contained in a cylinder, this empty water bottle, for instance, we're going to know how it responds to changes in pressure and temperature and volume because we've done it over and over again, repeated experiments. The main thing to know about gases is that gases have weight, they take up space, they exert pressure, and gases fill the container. In this particular, again, this empty water bottle, the gas isn't just located on the bottom, there's gas throughout this. Now, there's different gases that have different weights, and that's kind of a little different animal in and of itself. But generally speaking, if there is a combination of different gases, they completely fill up the container. Okay, the gases exert pressure. Think about a balloon. The more gas you put into a balloon, the bigger the balloon gets because the gas is exerting pressure. And if you drop that balloon, or actually even to weigh the balloon, you would notice that a balloon full of air weighs more than an empty balloon. Okay, so these are all the things that gases do. Okay, well, remember we talked about the kinetic theory a few presentations back, so we're going to review that a little bit just to remember because the kinetic theory is all about gases. All right, even though we can use it and talk about solids and liquids as well. Remember, all matter is composed of tiny particles. That's the first step. 2, the particles are in constant random motion. Okay? 3, all the particles are colliding with each other and the walls of their container. And lastly, that particles lose almost no energy from these collisions. Okay? So this should all be reviewed. If you don't have those down in your notes, make sure you write them now because there'll be some quiz and test questions about the kinetic theory. Boyle's law. We're going to talk about 2 different laws today, and the first one we're going to talk about is Boyle's law. Boyle's law describes the relationship between gas pressure and the volume of a container. We don't care so much about temperature. It's kind of the unnamed variable because there are 3 variables with gases: pressure, volume, and temperature. And each law usually deals with only 2 of the different relationships. So Boyle's, again, talks about pressure and volume of a container. So there are 3 factors to Boyle's law. 1, if you change the pressure, okay, you change the volume, right? And the temperature, again, the third one, we're not changing it at all. And so we can look at this and say, think about like a water bottle. You guys have all seen a water bottle. You put the lid on it and you start twisting it. You're changing the volume. So if we change the volume, what happens? Well, the pressure increases because eventually it'll blow the cap off, blow the lid off, which lets you know that the air pressure inside that bottle has increased enough to do that. Okay. Let's talk about explaining Boyle's law. So it says if you decrease the volume of a container of gas, the pressure of the gas will increase. And we just talked about that, how you take a water bottle, you decrease the volume and you increase the pressure of the gas. And then the opposite of that is true. If you increase the volume of a container, the pressure of the gas will decrease. Think about a syringe. If you take a syringe and you pull the plunger back, all of a sudden you've drastically increased the volume of that container. So what happens? All of a sudden stuff starts getting sucked into the syringe because there is a negative pressure on that gas. Again, here's a little picture that kind of explains that. If you pull up on the lid, the pressure decreases. If you push down, the pressure increases. Okay, and then the pressure increases or decreases by the bouncing of the molecule off the wall. That's how we measure pressure. Okay? The formula for that is P1V1. So the pressure and volume of the first container is equal to the pressure and volume of the second size of that container. Okay, so we can move these variables around in formula to figure out the difference of volume or the difference of pressure, depending on what we want to do. Next law we talked about is Charles's law. Charles's law, he describes the relationship between gas temperature and the volume of the container. Okay, so again, there are 3 factors, just like Boyle's law. He talks about the temperature and the volume, so the pressure doesn't change. So he maintains the same pressure. Took a little more doing with his experimental apparatus when he worked on this law, but he basically made sure that pressure never changed. So what did change? The temperature and the volume of the container is what he was looking at. All right, so let's look a little bit more at Charles's law. So basically, Charles' law says if you increase the temperature of gas in a container, the volume of the gas will increase. The good common example for this is when you're boiling something on the stove. You put the lid on top of it. And if it's a good tight sealing lid, or even like say a pressure cooker, and you increase the temperature, the volume wants to increase, okay, because it's going to expand, all right? And the opposite is if you cool that temperature down, cool that gas down, the volume of the gas would decrease. So I don't know if you've ever had an empty water bottle, like say left over in the car on a hot day, and you come out in the morning when it's really cool outside, that water bottle is all kind of sucked in and squishy. Okay, same thing for a balloon. You blow up a balloon in a hot room on a hot day, and in the morning or at night you bring it into the air-conditioned house. The balloon will actually get limp. Okay, because the volume is decreasing inside. All right. Now you'll notice right here again shows a little example on the bottom of the temperature. All right, and remember we are maintaining pressure. So the pressure we want to be about the same. So we're just going to change the temperature and the volume. So our formula is very similar to Boyle's law, except we're looking at volume and temperature instead of volume and pressure. So it's volume and divided by the temperature on the first side equals the volume of the temperature on the second side. So V1 divided by T1 equals V2 divided by T2. Okay? So that way we can predict what's going to happen. And that's it. Thanks for watching.